Hi, everyone. I'm Shadaj, and today I'm really excited to be talking about data science in Scala with ScalaPy. So let's just dive right in. Why ScalaPy? So the core idea is that today data science has a split ecosystem. We see Scala being used in a lot of production environments for handling large-scale data processing and those types of production applications, while Python is really useful for experimentation. And you see things like Jupyter notebooks, which have you've developed this ecosystem around Python for doing quick experiments and exploring data. And we also see this in the types of libraries that are available on both ends. Oh, apparently there's no audio. There might be audio. Okay, apparently it should be fixed. But we see Spark, which is built in Scala for handling large data sets, whereas NumPy has this really rich set of APIs for manipulating matrices, using linear algebra algorithms. And so we kind of see this split where Scala is really good for kind of these production large-scale uses, whereas Python is better for experimentation. And there's no real kind of crossover here. There are not many libraries in Scala for experimentation, and equally not many libraries in Python for these types of large-scale data science. And so us as developers and data scientists, we often have to perform this context switch between these two languages. So you might start out in Python, do some exploration of some machine learning models, and then we have to switch to Scala for actually productionizing that. And that's a really expensive context switch. So how can we bring Python and Scala together was the question that kind of started the exploration of ScalaPy. We have these two ecosystems, we want to use them together. How can we bring them together? And that's where ScalaPy comes in. So ScalaPy lets you use Python libraries from Scala code. It lets you do this both in JVM and native code. So you can run it regularly with Scala on the JVM, but you can also compile your code ahead of time with Scala native. You get a seamless interoperability layer, which means that any type of Scala value can be shared to Python. Any type of Python value can be brought into Scala without any trouble. And you can use Python values from your Scala code as if they were just regular Scala objects. And lastly, you can get a fully type-safe interface. So especially in our Scala code, we're really focused on having type-safe code, and that's really helpful to catch bugs before they happen in production. But Python's a dynamically typed language. So ScalaPy gives you the ability to create type facades, which lets you add static types on top of Python libraries so that when you're interacting with them from Scala, everything's type safe. So before we jump into the internals, let's write some code. ScalaPy works with Jupyter notebooks, and you can use them through the Almond implementation of the Scala kernel for Jupyter. Here, I've actually loaded it directly into Google Colab, which is a hosted Jupyter environment. So we're going to go through two examples. So the first, we're just going to do some simple kind of linear regression using TensorFlow. And in the second, we'll build up a full deep learning model. So to get started, let's load ScalaPy. OK, I need to approve this. So we get some nice utilities here provided by Almond that let us import libraries just using a regular Scala import statement. And then I can load up ScalaPy. So we see that we've loaded up ScalaPy. And then we can just start talking to Python libraries. So let's say we want to use NumPy. In Python, NumPy is a module. And so in ScalaPy, if I want to load that into my code, I just use the py.module API, which imports a module. And it exposes it as just a regular Scala value. This is a val, so just regular Scala code here. We're also going to use TensorFlow. In this case, we're loading the TensorFlow 1 compatibility module, since I haven't been able to port this example over to TensorFlow 2.0 just yet. So we're going to be using the TensorFlow 1 API. So we've loaded TensorFlow, we've loaded NumPy. Now let's create some training data. So we're just going to do some simple linear regression. So first, we want to generate 100 random numbers for our x points. So now we can just use NumPy. We can call API methods just completely regularly as if it was a Scala API. But you'll notice that this code is actually identical to what you'd write in Python. One of the key goals of ScalaPy with that seamless interop layer is that you should be able to take any examples you see from the Python world and port them to Scala without any trouble. Now, in this case, our APIs are going to be dynamically typed because we just loaded a module, so ScalaPy doesn't know what specific static types they should have. So that makes it really easy to get started using your favorite libraries without having to define your static types. But we'll see later in this talk how we can actually then, once we want to productionize this code, install some static type definitions that let us make sure that we're interacting with these libraries safely. ScalaPy also handles all the nice Python goodies like operator overloading. So here we can scale this vector of a bunch of integers, add something. And so here we're just setting the y-intercept and slope for training data. And so what our goal is going to be now is setting up kind of a TensorFlow graph, which will try to infer the y-intercept and slope of these points just by looking at this training data. So you see we have our training data generated. Again, it's all just regular Scala values. Next, we initialize some TensorFlow values. So now things get a bit more interesting. So we want to define a TensorFlow variable, but we want to kind of initialize it as a random value that's uniform from -1 to 1. Now, TensorFlow requires us to give it a Python list, which describes the dimensions of this tensor that we're going to be initializing. And so here we can take a Scala sequence, this is a regular Scala sequence, and just convert it into a Python sequence instead by using this toPython proxy. We'll see why we have this special proxy method later. Similarly, we can initialize some zeros. We can have a one-dimensional vector of zeros for our intercept. And then we just define our graph by saying that our predictions should always be our input x data multiplied by our slope, and we add our y-intercept. All right. So now we've initialized that. Then we just have a couple steps remaining. This is just like the type of code you'd write in Python, but we're doing this all from Scala. And so we can use whatever Scala goodies we want as well. So we're going to initialize our optimizer. And lastly, here now we can mix a bit of Scala and Python together. So we're going to do a loop of 200 iterations. In each one, we'll run an iteration of training. And at every 20th step, we'll print out the current slope and y-intercept that we've predicted. And again, we can use string interpolation, things like that, and mix and match these Scala and Python values. You'll notice here we're doing this thing called a bracket access. So we'll see some later that there are some syntactic features in Python, like using brackets to access elements from an array that don't have an equivalent in Scala. In Scala, we just use regular method calls for loading values out of sequences. And so if we want to kind of map those Python syntactic features into Scala, we offer custom APIs. So in this case, we use bracket access to perform that type of bracketing operation. And we've run it, and we see that we are able to predict our slope and y-intercept. And this was just using all TensorFlow under the hood. But now, to see a bit more of an interesting example, I'll go through this a bit faster since then we can jump into how ScalaPy actually works under the hood. But what's really interesting here is TensorFlow supports GPUs. Google Colab offers us GPU backends to run our machine learning operations on. And ScalaPy doesn't limit how you can use your Python libraries. So if we want to use TensorFlow with our GPU backend, we can do that with no trouble at all. ScalaPy supports any Python library you can throw at it. So we'll get started again with this similar type of initialization. Here we're going to be doing a bit more of a fancy code to set up a hook that will intercept Python's print requests and pipe them through the JVM instead, just so that we can see the logs that TensorFlow prints out. Then we import NumPy and TensorFlow. We load the MNIST dataset. So these are pictures of handwriting. So we're going to be recognizing handwriting. So we loaded some data. We're going to use the Keras API provided by Python. Again, this is very familiar stuff. But we see things like here, for example, we can use a regular Scala tuple, pass it in. We can have named parameters, just like we have in Python, but here we're using Scala's named parameters. And so we're able to initialize a bunch of convolutional layers. We can print out the summary. So this is TensorFlow showing us what our model looks like so far. We can add our final layers to flatten out our kind of two-dimensional tensors into just a flat tensor, and then apply some dense layers, print out our final model. And then we can actually train. And this would be super slow on a CPU, but because we're running on Colab and we have access to a GPU, we'll see that we're able to run through these training steps super fast, even though we're dealing with a huge data set of images. So we can let this run, it'll be done in a couple seconds. And then lastly, we can just say, okay, I want to evaluate my model on my test set. I know that TensorFlow will give me back a list of doubles. I can convert that into a Scala sequence of doubles. So here we see kind of the transformation abilities where we can take Python values, convert them into Scala, and print out our test loss and test accuracy. And so after we run through, we see that we're getting an accuracy of 98.97%. So that's really awesome. So in just kind of a couple lines of code without really anything too out of the ordinary, we're able to use the Python APIs just like regular, call the APIs that we see in the Python docs, but do everything from Scala. And that's what ScalaPy is all about. So now that we've seen ScalaPy in action, let's talk a bit about how it works, because that's where all the magic happens. So to begin, let's talk about how ScalaPy talks to Python. There are a lot of interop projects for Scala, like Scala.js to compile Scala to JavaScript, Scala native to compile Scala ahead of time to native code. ScalaPy is a bit different in how it achieves interop. So the approach that ScalaPy takes is it actually embeds a Python interpreter inside your runtime environment. So you load ScalaPy as just a regular library. You just add it, and that's how we were able to bring it into our Jupyter environment without any special tricks. ScalaPy will initialize a CPython interpreter in either your JVM environment or Scala native, depending on which backend you're using. And then all that changes between these two platforms is how ScalaPy talks to the interpreter. So if you're on the JVM, ScalaPy will use JNA, which is a nice kind of high-level foreign function interface implementation. And so it'll use that to talk to the CPython interpreter. And on Scala Native provides us kind of a direct foreign function interface that we can use. And then all the magic kind of is shared across these platforms. Other than this kind of how we actually specifically talk to C functions and deal with pointers, everything is shared across the two platforms. So for example, in the CPython interpreter, if we have these two values, like an array and maybe a reference to a module, TensorFlow, then we can have in ScalaPy two pi values. So a pi value is kind of an opaque reference to a Python value. So pi values hold a reference to the actual native pointer for this underlying Python value, but nothing's typed at this level. Any reference to any Python value is just stored in this pi value. Now, the reason we have this intermediate layer is a lot of the work that goes on in ScalaPy is for heap synchronization. Because since we're embedding the Python interpreter, we have a whole heap for all of the Python objects, as well as a heap for your Scala objects. And so we need to make sure that references across this boundary are all kept safe. And we make sure that we're not using something after it's freed or keeping anything around longer than we need it. So this pi value handles that level of making sure that all our references to Python objects are safe. But what you actually deal with when you're interacting with Python objects in your end user code are these nice high-level typed Python facades. So you have things like pi.list, which is representing a Python list, pi.module for modules, and more. And so you just deal with these types, and ScalaPy handles all of the interaction with the underlying Python interpreter for you. So to look a little bit into kind of the inner bits of how ScalaPy handles this, we actually have a very lightweight kind of platform object. And the goal of this platform object is to provide the core C foreign function interface kind of APIs we need for both JNA and Scala native through a common interface. So here we can use type aliases to say that on JNA, a pointer is just the JNA pointer type, whereas in Scala native, it's a pointer of bytes. And we have additional types for pointer of pointers. Scala native uses zoned allocations. And so we have this with zone, which on Scala native will actually create a zone on JNA, since JNA just uses kind of regular Java garbage collection to determine when to free pieces of memory. We don't need it, so we just use a no-op. And then we have things like, for example, if I want to allocate a pointer to a pointer, we have different APIs for how to do that on JNative versus Scala native, but we kind of wrap these both into a common API. And so then we can share the entire logic for actually talking to specific Python APIs. In addition, Scala native is, or Scala in general, we often have lots of threads. We have really great support for concurrency in Scala through things like futures. And so we want to make sure that you can bring Python into your Scala code without having to deal with thread safety issues. So Python has this thing called the global interpreter lock. That means that whenever you kind of call into the Python interpreter, you have to hold this lock. And ScalaPy will handle that automatically for you. So whenever you're interacting with Python objects, it'll make sure to grab the lock exactly when necessary and hold it for the minimum amount of time to perform those interactions across the barrier with Python. So now that we've learned a little bit about how kind of ScalaPy deals with the Python interpreter, now we can talk about the higher level pieces. How do we mix Scala and Python, which have some similarities, but a lot of differences? How do we mix them seamlessly? So when we were working in our Jupyter notebooks, we were able to get started really quickly. And that's a result of ScalaPy's dynamically typed APIs. So by default, whenever you import a module, or if you're trying to load something from the global scope, you get a dynamically typed API. This is similar to Scala.js's js.dynamic. So we have a py.dynamic equivalent. So the reason that you start out dynamic is you just want to get up and running with NumPy or TensorFlow or your favorite Python library. You don't want to deal with all the effort of having to define static types, especially if the library authors in the Python end have not kind of declared specific types for those API methods in things like docs. So you just want to get started really quickly, and ScalaPy lets you do that. So by using Scala's dynamic type, which makes it easy to introduce dynamic types into existing Scala code, you can interact with all of these objects as if they were dynamically typed values in Scala. So for example, if you take a list and you call .append, since your list is a dynamic type, this actually expands to, by the Scala compiler, to this apply dynamic call. And so this means that you can quickly start accessing APIs without having to create all your definitions. You also get a feature in ScalaPy called what we call Python interpolation. So Scala has string interpolation, which is a really powerful feature, and it's actually defined in kind of an abstract manner. So we can define our own custom interpolators. ScalaPy has the PyQuote interpolator, which lets you define snippets of Python code where you can inject variables from Scala. So for example, I can define a list, a Scala variable, and say, I would like you to execute this code, getting the sum, and inject this list inside there. Now, what ScalaPy actually does under the hood is actually creates a temporary scope, loads all of the things all of the values you're injecting into that scope, and then just executes that expression. But this makes it really easy. For example, if you see a snippet of code on the web and you just want to get it running in your Scala code real quick, without even having to translate anything into the Scala equivalents, you can just run it in your Scala code. Another thing that we need to kind of bridge between Python and Scala are specific syntax elements that exist in Python but don't really have an equivalent in Scala. So for example, one of these is the with keyword. So with lets you say, take a value and kind of temporarily use it in a scope and free it afterwards. So this is a common pattern used for files where you say, I want to open up the file, do some operations with it, and then release it afterwards. One of the really nice things in Scala is because we have such nice language features like this currying syntax, we can actually get a fairly close equivalent to the Python syntax without having to modify the compiler or anything. This is just regular APIs provided by ScalaPy. So for example, we can do py.with. We pass in the value we want to temporarily use, as well as a function for what we want to do once we've kind of temporarily loaded that value up. So for example, we can get a file and grab its encoding. Another thing we see here is we're going to start taking a look at more static types. You can take Python values and cast them into Scala types at any time by calling .as. So that's what we're doing in this case, where we get file.encoding, which by default is a dynamically typed value, but we say, hey, I know this is going to be a string, just convert it into a Scala string for me. Now, another really cool thing that ScalaPy handles is a reverse interop. So far we've seen Scala calling Python methods, but we can also send Scala code into Python so that Python can call back to Scala. So we achieve this by having a conversion between Scala functions and Python lambdas. So for example here, if I define a function that takes an int and adds 1 to it, I can actually convert it into a Python lambda and use it for the map function call. So Python has a map API similar to kind of how Scala has it. And so map takes the first parameter is a lambda, which describes the transformation for every element. And the second second parameter is the sequence of elements that you want to transform. So here we can just say, I would like you to map, but using the Scala function. Now, ScalaPy will detect that you have a Scala function, but you're trying to call a Python method. So it'll automatically introduce a conversion that wraps this into a Python lambda. So this actually requires a bit of kind of trickery under the hood to get this to work right, because again, the C Python interpreter and the JVM or Scala native have independent heaps, and they have their own garbage collection schemes. So we have to make sure that we're handling these references across the boundary safely. So if I have a Scala function that I want to send into Python, what I first do is register it with this reverse reference manager. So this is kind of a map that sits in our Scala code, which keeps track of all of the references that Python currently holds to Scala values. What we do is to represent this reference in the world of Python, we create what we call a tracker object. So a tracker object kind of represents a reference to the Scala function, and it has a finalizer installed so that we know when Python no longer needs the reference to that Scala value. And so we can clean things up appropriately. Then we create a general handler. So when you want to create a lambda in Python, you just have to pass it a C function pointer. Since we can only pass in C function pointers, that means this must be a static function definition. So you have a general handler that will be used for all lambdas. But what the general handler will do is it'll take a look at the specific lambda instance it's being used for, pull up the function associated with that lambda, and then call that Scala function under the hood. And so with all these pieces in place, we can just create a lambda that says my implementation is the general handler, but I also want to associate this tracker with it so that when the general handler is called, it can look at the tracker, pull up the Scala function associated with that tracker, and execute it. And so in this way, we're able to send Scala code into Python while making sure that all the references are being handled safely. So another peek kind of under the hood, this actually just ends up resulting in you have a common handler which unwraps your tracker object into a Scala function and calls it. And then for every type of Scala function we want to convert into Python, all we do is create this kind of Python, a thin Python wrapper function, which extracts out all the args and calls your original Scala function with it. And so through this, you can take any Scala function you want, regardless of kind of what it's doing. It might be interacting with other Java libraries or anything, and just send it into Python safely. Another place similar to functions where we have a bit more of a complication is sequences. So converting sequences from Scala to Python involves a various number of trade-offs. So one kind of simple way to convert a Scala sequence into Python is copy all the data into a new Python sequence. So that's actually what ScalaPy used to do at first. It would always just create a copy, but this is quite expensive. You waste a lot of memory because you're copying all that data over, and that's not great for things like when you're handling large data sets. And it also kind of introduces this upfront cost where you have to convert all of the elements in that sequence into their Python equivalents. What ScalaPy is 0.4.0, which is kind of what we're discussing in this, and that's the latest release of ScalaPy. What that does is it also offers a Python proxy conversion. Now, what a proxy does is it's a very thin layer that sits inside Python that references the original Scala collection. And so every time a Python library wants to access an element from that proxy, it'll actually go all the way into the original Scala collection and grab it on demand. So this results in reduced memory usage since you just have a very thin layer sitting in Python. And also eliminates the overhead of converting a bunch of elements. For example, if you only expect one of the sequence elements to actually be loaded. So we can kind of see this in action in this example where if we have, for example, side affecting apply method in our sequence, we see different behavior where the copy kind of loads everything ahead of time, whereas the proxy, when you print it out and Python kind of iterates over every single element, then you see those elements being requested. And how this works under the hood is actually just powered by the function conversions we saw earlier. So if we look at the difference between our Scala conversion and our Python sequence, it's just two different methods that we have on each end for getting a specific item. So you have apply in Scala, but underscore underscore get item in Python. And we want to kind of wire these to each other. So what we do is create a Scala function, which points to the apply method of that sequence that we want to convert. Then we convert it into a lambda using the existing logic we already have. And finally, we just wire the Python sequence to use that apply method. And so now every time someone wants to get an element from a Python sequence, it goes across the boundary into Scala and grabs the element you want. And then we perform a conversion on the Scala element in kind of when we're returning that element back so that Python gets a Python value that it expects. So under the hood, it's actually quite simple. And this is kind of the result of ScalaPy providing conversions for these very core primitives like functions, is that we can just handle these types of proxies super easily just by defining a very thin layer. Lastly, let's talk about maintaining type safety. So type safety is kind of the core part about Scala. We really care about type safety, and it's one of the great things that the language provides us. So initially, ScalaPy just provides some core type mappings between Scala types and Python types. But in addition to this, it also provides a complete type hierarchy that mirrors the types that exist on the Python side. So you have things like objects, modules, you have types for individual modules, things like here's a none object in Python, here's an integer object. And we have this entire type hierarchy that's available to you in your Scala code for interacting with Python safely. You can also define custom facades. So for example, if I want to interact with the random module, which provides a random number generator in Python, I can define this using syntax very similar to Scala.js. A lot of ScalaPy is inspired by Scala.js because Scala.js really figured out a great model for interacting with dynamically typed languages safely from Scala. So you define this at py.native trait. You define what methods are available. In this case, we're just saying there's a uniform method that takes two doubles and returns a double. We implement it with py.native, and now we can take our imported module, cast it into this facade using .as, and now we can access all of these kind of type-safe methods. And if we pass in the wrong types of arguments, we'll get an error at compile time. So now we can deal with Python libraries safely. What this actually results in under the hood is the synthesization of some type classes, and that's how ScalaPy handles conversions between all of these without actually requiring any special kind of compiler tricks to handle these. This is really powerful. So when you're dealing with data science, especially with regular Python libraries, you are often afraid that you're going to make a small mistake and run your big batch job and it'll just crash halfway through, and that's not fun. With ScalaPy, you can write out all of your data science operations and make sure and be confident that your code will actually execute as you expect. There's also some really cool applications of these. So ScalaPy is actually already compatible with Scala 3 Dotty. Maxime, who's a master's student at EPFL, actually built this library called TensorFlow Dotty on top of ScalaPy that offers shape-safe tensor operations. So for example, if we do a reshape, it'll error out at compile time if the dimensions don't match up, if the product of all the dimensions don't match the new set of dimensions that we want. Similarly, it'll make sure that you're reducing on the right dimensions of your tensor. And so this makes it much easier to work with libraries like TensorFlow while being safe about these types of complex bits. And as a preview, something that I'm really excited about that's coming soon to ScalaPy, it's not ready just yet, but it'll be ready soon, is the ability to auto-generate type facades. So Python already has these awesome Python type definitions in these PYI types that are being adopted by the community now. So we can actually take advantage of these and use these Python type definitions and generate Scala type definitions. So here's kind of a preview of what you can get, where you even get the full type hierarchy, where you say, oh, a Python byte array extends a Python mutable sequence of ints. And it also extends byte strings, and we get all of the methods provided to us by Python. And you just run kind of a single command, and ScalaPy will generate all of these types for you. So the hope is that this will make it even easier to get started with your favorite libraries, since you'll be able to use them in a type-safe manner all the way from the beginning, instead of having to move from dynamic to static over time. So that's ScalaPy. ScalaPy lets you use Python libraries from Scala code in both JVM and native code across these platforms. So if you want to experiment in something like a notebook, a JVM is great. If you want something to be super fast, use low memory, have low interop overhead, Scala native is great. And your code will run identically on both platforms. You get a seamless interop layer that handles all types of data structures, conversions between them across both platforms. And you get a fully type-safe interface that you can opt into over time to make sure that your production code is safe. So you can get started today. Check out ScalaPy at scalapy.dev. We have a GitHub, and you can contribute there. And we also have a Gitter community where we discuss what's going on with all of our kind of applications of ScalaPy. If you're curious about learning more about how ScalaPy actually works under the hood, I've actually been working on a paper which will appear at the Scala Symposium at Splash this upcoming week, which goes into a lot of the details of how we handle all of these intricate details of mixing the different semantics of Scala and Python. And I'd like to thank my advisor at Berkeley, Professor Kaushik Sen, for guiding this project and getting it to be super precise with the way it handles all of these different semantics. And now I'd like to answer any questions.